In this video, we're going to learn how to solve trig equations involving multiple angles. This is section 6.3 in your textbook. The best way to describe or to teach how to do this is just to demonstrate a few different problems, and hopefully you'll get the hang of it. So, you need to know all of the skills that you've learned in section 6.1 and 6.2 to solve trig equations, and then solving trig equations with multiple angles is just one more step. So, let's start off with an easy one. We have the sine of 2 theta is equal to negative root 3 over 2. So treat 2 theta as its own angle. So think about what could 2 theta possibly equal. Well, 2 theta is an angle that when you take the sine of it should equal negative root 3 over 2. So if you have that chart memorized, you should know that 2 theta should have a reference angle of 60 degrees because the sine of 60 is root 3 over 2. But remember that all students take calculus, so since this is negative root 3 over 2, that the angles, that 2 theta should be angles in quadrants 3 or 4. So, an angle with a reference angle of 60 in quadrant 3 would be 240 degrees, and an angle in quadrant 4 with a reference angle of 60 would be 300 degrees. But, if you look, it says for all theta, we want to find all theta measures between 0 and 360. But right now, we're finding 2 theta. So that means if we look at this inequality and multiply everything by 2, then that means that 2 theta has to be in between 0 and 720. And I got that by multiplying everything by 2. And it's because right now we're not looking for theta, we're looking for all possible values of 2 theta. So, there's actually 2 other angles that 2 theta could equal. And it's the coterminal angles to 240 and 300. So if you add 360 to 240, you get 600. So it's another angle that 2 theta could equal. And if you add 360 to 300, that would be 660. So it's another angle that 2 theta could equal. But it's not asking to find 2 theta, it's asking to find theta. But now is the easy part, because if we know 2 theta, finding theta is easy. All we have to do all we have to do is divide everything by 2. So 240 divided by 2 is 120. 300 divided by 2 is 150. 600 divided by 2 is 300. And 660 divided by 2 is 330. And I should probably turn off my phone before doing these videos. So, you should always check your answer by plugging it into a calculator if you have that luxury. So, I just want to show you how that would look and just to prove to you that we did the right thing. So if I open up this calculator, first, remember our first answer was 120. So the sine of 2 theta, the sine of 2 times 120, came out to root 3 over 2. If we do this again, but now plug in, let's just do it again this way. But now plug in 150 for theta. So we have the sine of 2 times theta, which our second value we got was 150, comes out to also negative root 3 over 2. And might as well check out the other two. If we do the sine of 2 theta for when theta is 300, the sine of 2 times 300 also comes out to negative root 3 over 2. And lastly, if we do the sine of 2 theta for when theta is 330, we will also get negative root 3 over 2. So that's a good way to check your answer by just plugging it back into the calculator. Alright, let's try another one that's slightly more complicated. So, this is a marriage of this section, 6.3, because it involves multiple angles, and also the previous section, 6.2, because it involves an identity. So if you see a trig equation that has multiple trig functions in it, first make sure that you can't just factor out one of the trig functions. And although you could factor out sine or cosine on the left side, that wouldn't really help us solve this equation because we wouldn't have it set equal to 0. And we should only factor when we have one side of the equation equal to 0. So if that's the case, if you can't factor and there's multiple trig functions, then it's an identity. So try to figure out what identity this most closely resembles, and hopefully you'll see that this is the sum of sines formula. So the sum of sines formula says that the sine of A times the cosine of B plus the cosine of A times the sine of B equals the sine of A plus B. So we can condense this left side of the equation as the sine of 2 theta plus theta, and the right side stays as 1/2. So that makes it a whole lot easier to solve, because now we only have one trig function. So now we know the sine of 3 theta equals 1/2. So again, this equation is asking us to find all theta between 0 and 360. If they didn't say that, then there could be an infinite amount of answers. Well, right now we have our angle is 3 theta because we're taking the sine of 3 theta. So although theta can be in between 0 and 360, if we multiply both sides of this inequality by, both sides of this inequality by 3, then we have that 3 theta has to be bigger than 0, or equal to, and less than 1080. So we have to find all the angles between 0 and 1080 that we could take the sine of and get 1/2. So the most obvious angle that 3 theta could equal is 30, because the sine of 30 is 1/2. We could find another angle that you could take the sine of and get 1/2, and that angle would be in quadrant 2, because remember, all students take calculus, so any angle in quadrants 1 or 2 that we take the sine of will give us a positive ratio. So the angle in quadrant 2 with a reference angle of 30 is 150. Now we got to find angles coterminal with 30 and 150. So there's also the angle coterminal with 30. So we do 30 plus 360 is 390. And then do 150 plus 360, and we get 510. If we do 390 plus 360, so the angle coterminal with both 30 and 390, that's still in between 0 and 1080, would be 390 plus 360, and that would be 750. And then if we also add 360 to 510, we get 870. So here are all the possible values for 3 theta in between 0 and 1080. But it's not asking us to find 3 theta, it's asking us to find theta. So now it's easy, we're just going to divide everything by 3, and we get that theta could be 30 over 3, which is 10, 150 over 3, which is 50, 390 over 3, which is 130, 510 over 3, which is 170, 750 over 3, which is 250, and 870 over 3, which is 290. And all of these angles are in degrees. So let's just do one more, and hopefully you'll have the hang of it by then. So hopefully you're seeing that the steps to solving these trig equations with multiple angles is just like solving any other trig equation, except the final step where we're not looking for, the final step where we expand out theta. If we know that theta is in between 0 and 360, then in this case, since in this third problem we're taking the cosine of 2 theta, we're going to find all measures of 2 theta in between 0 and 720. And we get that by multiplying both sides of this inequality by 2. So first we need to figure out what 2 theta could be. So here we have a quadratic trigonometric equation, and I noticed that because of this little exponent of 2 up here. So whenever I see a quadratic, I want to get all of my terms over to one side of the equation. So I'm going to multiply 1 on both sides. So I'm going to have 2 cosine squared of 2 theta minus the cosine of 2 theta minus 1 equals 0. So you can use the quadratic formula, or you could factor this using the guess and check method. So I could factor this by writing it out as 2 times the cosine of 2 theta, and then leave a little space, and then open and close parentheses, and then write the cosine of 2 theta here, and try to figure out what terms go in this blank and this blank. So it's got to be 1 and negative 1, because I know that the last term in the quadratic in the previous step is negative 1, so those are the only 2 integers that multiply to negative 1, and I have to make sure that my middle term comes out to negative 2 theta. So the only way I could do that is by putting a negative 1 right here and a plus 1 right here. So now I have 2 equations. So I'm going to highlight this equation in blue, and I'm going to set this equal to 0. And I forgot to write that over there. that this factor left side of the equation should equal 0, because that's what it equaled when we began. So 2 times the cosine of 2 theta plus 1 could equal 0 using the zero product property. So if I solve for the cosine of 2 theta, I get that the cosine of 2 theta could equal negative 1/2. And I get that from subtracting 1 and dividing by 2. And I just did it in 2 steps just to save room. So remember that 2 theta could be any angle in between 0 and 720. So let's write out all the possible values of 2 theta. Well, 2 theta has to be an angle with a reference angle of 60, because the cosine of 60 is 1/2. But we want to get negative 1/2, so we have to find angles in quadrants 3 or 2 or 3 rather, and I guess it's the same idea, I just like saying the smaller one first, because that's where cosine is negative. So an angle in quadrant 2 with a reference angle of 60 would be 120 degrees, and an angle in quadrant 3 with a reference angle of 60 would be 240. And we could also find angles coterminal, because 2 theta could be in between 0 and 720. So I'm going to add 360 to 120, and I get 480. 240. Nope, 480. That was right the first time. And add 360 to 240 and get 600. Alright, let's go look at the other equation now. So I'll highlight that in a different color. This other part of our factored quadratic. And we got that to be the cosine of 2 theta plus 1. If that equals 0, then our quadratic will be true. So I'm going to solve for the cosine of 2 theta, and I get that the cosine of 2 theta equals negative 1. So that means that 2 theta, in addition to 120, 240, 480, and 600, could also be 0 degrees, because the cosine of 0 is negative, I think I made a mistake. Oh wait. Here's my mistake right here. This was a minus 1, and that's a plus 1. So let's fix this. Turn this into a minus. So we'll have a plus 1 over here. So we have the cosine of 2 theta equals plus 1. So now 2 theta could equal 0. Sorry about that. And 2 theta could also equal 360, because that's the angle coterminal with 0. So, last step, we have all of these values for 2 theta, but we're not looking for 2 theta, we're looking for theta. So I'm just going to multiply both sides of the equation by 2, and I get that theta could be 120 over 2, which is 60, 240 over 2, which is 120, 480 over 2, which is 240, 600 over 2, which is 300, 0 over 2, which is still 0, and 360 over 2, which is 180. And again, all of these angles are still in between 0 and 360, and you should also plug them into a calculator to check that they all, when you plug it into the original equation, will equal 1. And if you do all that and it checks out, then you're done. So I hope you found this video helpful, and have a good one.